Hi guys, this is CEO speaking again. As an addition to our PLC trainers, I'm going to start today introducing some electronic work, and it's going to be a pleasure to have as a first little project the famous Larson Scanner. And as some of you may still recall, he was named after Glen Larson, who produced both the original Battlestar, Galactica, and Knight Rider. Okay. I've seen this even on some buses in the transportation system in Washington, D.C. a couple of years ago. Now we're going to do one of them at a smaller scale. So I have one already prepared for you, just to see how is this working. So take a look. We have 9 big LEDs here, 10mm diameter each, and all the electronics is driven by this very tiny microcontroller, and because of this is containing options for energy saving. So the batteries you're going to power with are going to last for a long time. So again, 9 LEDs, and as you can see, it's not only a logic arrangement, but it's a combination between logic and analog, because the lights are not just going on and off. That's simulating exactly the famous Larson scanner. It's even having a tiny button here where you can adjust the pace. You see now it's going faster, now it's going much slower. I take the medium speed. It's a reasonable compromise, so it has 3 speeds. And as you notice, there are not many components here to solder. If you count, there are exactly 9 resistors, because you have 9 LEDs, you need 1 resistor for each. The resistors are always required for protection. There is one very little capacitor over here, and the little push button we use to switch between the 3 modes, and that's it. Okay. So we're going to use it as a sample. Now we have here a kit, a complete kit. You can find it. It's made by Evil Mad Scientist. You go on the net, you'll find it right away. evilmadscientist.com, very easy. Okay. Let's open it. So what do we have inside? We have a little bag with the printed board and a little box holding the batteries. Okay. But it's a nice box because it also has a switch for on-off. Okay. Okay. So nicely made. This one we're going to put at the end. And here is a very nicely made printed board. Okay. Here is the microcontroller ATtiny2313. This is the one doing the whole job. So the software regulating all the moves of the LEDs is inscripted inside. Okay. So now what do we have to do is just to hold it into the same position as the sample already made. And we're gonna take the components out of the bag. See what do we have. So you have here the resistors. Each of them, if you consult the documentation, is 16 ohm each, because the resistors, if you can still recall the color bands, it's a brown, which is 1, is a blue, which is a 6, and the black. And the black means no multiplier. So 1 6 is 16. 16 ohms. So 16 ohm each. The golden rig at the end is just about the tolerance. Okay. Okay, so we have the resistors. These are going to be the first things we're going to place here, because we always start by doing soldering, placing the components having the smallest footprint, so they are at the lowest level. Just want to know how to fold the resistors. Is going to be let's see, this one, yeah, okay, so we know what to do. We're going to try folding resistors. Let's see if he was the good one. Okay, so we're going to align all of them in the same position. To make the soldering a bit easier, we're not going to plug all of them in one shot. You're going to see what I'm doing. I'm going to prepare them anyway to make sure that they're going to be ready. This way I don't have to bother measuring every time where do I have to fold the terminals. And there are not too many. There are only 9 of them. To solder, it won't take long. Okay. How many? 2 more. Like this. So now I'm picking up and I said I won't plug all of them in one shot. Oops. Okay, to here on this side I'm going to place some on the other side as well. Okay, this, so I leave a free room between the two. Okay, one more. This one I didn't plug in the right position. I like them to be oriented the same way. Sorry for that. Okay, and one more on this side. That's it. So now we just turn on the other side. We pick up some solder. We clean the tip of our iron, and then we start soldering. You don't have to hold it for too long. You're going to see that I'm soldering on one side like this, and then I'm going to pass to the next, and to the next, and to the next. So now I want to make sure that the resistors are still in the right position. I'm cutting the excess. Never direct these to your eyes, because you'll never know what's going to happen. So safety first. And I have the habit to even hold them with my finger to make sure that nothing is going to jump. Okay. Okay. So next thing I'm going to do, I'm going to solder the terminals which remained floating into the air. Now that I know the resistors are in the good place. So these ones and the other side, all of them. I'll also check all of them to make sure we don't hold them for long. Okay, good. So now everything looks okay so far, and now we take care of the remaining resistors. Okay. So this is the right position for the resistors, and we still have 3 more to plug. Oh, not even, we still have 2 more. It seems that they left us a spare. It's a very good choice, because the beginners have a bad habit to damage part of components. Okay, so now we do exactly the same thing as before. We are soldering one side only. Clean the tip. We hold the board, so you don't need to place it into a special holder only for that. It's going quickly. So if any adjustments are required, we can see right away. So the resistors, they look like in the right position. Now we can cut the excess. Never forget, don't direct them to your eyes. Safety first. I'm reminding you that preventing jumping, I'm always keeping my finger on the ends of components. You never know. Okay, and now we solder the remaining terminals. Okay, so we only soldered one side. Okay, and now it's time to solder the other ones. Okay, to make sure we go and check on both sides. And now we solder here. Okay, check also. Supposing everything is checked, you're going to notice from time to time that little pieces of solder may remain. You don't worry much about that, okay? But at the end, I'm gonna use a standard toothbrush to remove the excess and to clean the circuit. So the first step is done. Okay, now I'm going to look here for the tiny switch, and this tiny switch only has 2 terminals. It comes here. Okay, and we do the same as for the resistors. Solder one side, we solder the other side. Done. Okay, now is going to be the tiny capacitor. So as you can see, the position of the capacitor is over here. We turn it over the other side. Just to check its position. It looks fine so far. So then we can solder the other one as well. Since both of them are soldered, remember, these pins are really dangerous if you direct them to your eyes. So always be careful about that. So this is done. What's remaining? The socket for the microcontroller. Okay. When the microcontroller is coming, it doesn't come actually with a socket, and if we watch, it has exactly 20 terminals, so 10 terminals per side. Okay. So if you want to make sure that nothing is going to damage, then you would need a socket. Okay. For this one here, I'm going to take the risk and putting no socket on it at all. Okay. So we turn it on the other side, and I'm only soldering one pin. Okay. I'm going to show you something very interesting about soldering integrated circuits, because you have to prevent them overheating. Okay, so I'm only soldering one terminal. I'm checking the position. If the position looks right, take a look what I'm doing next. I'm picking up the same side where I started, but I won't solder the next terminal. I jump one over one, and I'm soldering every second position after the previous. Okay, like this and like that. You see this? And on the other side, I start from the top and I jump over one. So only soldering the second one every time. You see this? And now I come back over the side I started with, and I'm soldering the remaining terminals. So this is the way you make sure that nothing is going to overheat. This is what you have to prevent to happen with integrated circuits, even with sockets, and with the most of the components, because they don't like high temperatures. Okay? Okay, done. So we're checking again just to make sure that no traces of solder are here between the pins, and to make sure nothing is going to remain. This is why we remove them by friction with our toothbrush. Please don't use this one again in your bathroom. Okay, so let's say this one is done. I forgot to give you an important detail, because I do this mechanically. Right here, if you can magnify it, Cameron, there is a notch on the integrated circuit, on any integrated circuit. And for this one, there are two notches. There is one like an opening in the middle of the package, and there is a little dot over here. This is exactly to identify where is the pin number one, because everything depends on the position of this pin number one. If you accidentally reverse the position of it, you're going to damage the package, surely. Okay, now there is one more step to do. We have to place the LEDs. For the LEDs, probably I'm going to do this into another video, how to play with the LEDs properly, because unfortunately in so many places and magazines, they tell you a couple of things which may not always be right about how to find, for such a diode, where is the anode, where is the cathode. The terminal marked on the most of the diodes is the cathode, but on this LED, even if it is a big format, 10mm diameter, there is no flat around the LED, and you cannot see properly because it's a semi-transparent body. It's not fully transparent to see what is the larger terminal, the one carrying the actual semiconductor. So what's remaining, they say, take a look at the two terminals and consider, let's say, the longer one being the anode and the shorter one being the cathode. But my good advice is don't trust, okay? To make sure we won't solder them for nothing, we're going to check these LEDs. Actually, we're going to check them one by one. I'm just making a bit of room between the terminals, just to make sure all of them are all right. And on the same occasion, we're going to clearly identify where is the anode, where is the cathode for each. So this way we won't be wrong, okay? This is my best advice I can give you. It doesn't matter what information you find in all kinds of places, even in good magazines, about length of the terminals. Don't trust this, okay? Trust what you can measure, okay? So here it is. I'm going to check. So yes, there is one terminal longer than the other. So yes, I'm going to assume that this is going to the positive. So we take a look now. Here we have a bench multimeter. There is a position on any multimeter to measure diodes, okay? And now if I'm touching the two terminals, take a look, I can see the light. So the terminal touching right now with my black of the multimeter is going to be the cathode. So I'm taking a look at it. Yes, the cathode is the shorter terminal. Anyway, this one is checked, and I'm going to check all of them to make sure they are in good condition. I have 2 of them checked. Now I'm going to check the third one. It looks good. Then I'm going to check the fourth one. Good too. It won't take long. Better to check than sorry. Another one. Let's pick it up from the longer terminal. That's it. So the shorter one I'm touching with the black of the meter is the cathode. That's it. So here, one more. All good. Okay. And what we're going to do, we're going to just align the LEDs like the ones we just measured. Remember, the positive was a longer terminal. We put with the positive in the top. Okay. So we're going to align them like that. Okay. Okay. So longer one in the top. Terminals remained folded because we had them checked before. Okay. At this moment we don't care much about the alignment, because the alignment is going to come after we solder one terminal. You'll always be careful not to put them reverse way. You won't damage anything, but the project won't work, and it's going to be pretty difficult to remove them after that if you do wrong. Okay, so we're close to the end. One more right here. Okay, so right now we just have to prepare them for soldering, exactly as we did for the resistors. We're going to only solder one side. So we're going to solder the top for each of them, only the top. It's not going to take long before we're able to solder the tops. One more. Okay, and right now you can see that the diodes are not all of them aligned. So what do? We are trimming the terminals. Don't forget, these pins are really dangerous if you allow them jumping into the air. Okay, so I'm trimming them all. Okay, one more. And right now we're going to focus on the terminal we just soldered before to make sure the diode is aligned in the position. So when it does, we just push the diode to stay exactly in place. You're going to surely feel it when you do the soldering. And if there is any excess, you're going to trim at the end. Okay, so okay, oops, I didn't last. Okay, last one. Very good. So let me see now. They look aligned. Everything is fine. Now we solder the other terminal remaining. Okay. So we're going to focus on the remaining terminal. Now we finished. We give them a last check to make sure everything is fine. Okay. Okay. Checking again the alignment. Everything good, everything good. I'm still trimming any excess, avoiding to direct them to my eyes. Okay, so if this thing is done, we give them a nice cleaning. We double check to make sure that there is no excessive solder remaining close to the LEDs. And now, since everything looks aligned and in place, the only remaining thing is to place the support for the battery. For the support of the battery, they did a nice thing, because you don't want this pair of wires to fold too many times and break. So they provided here on the printed board 2 additional holes. So we're going to pass the whole cable through the holes, and then we're going to solder in the other remaining hole like this. Okay, so let's see both of them. Okay, like that, exactly as we did with the resistors and the LEDs. We are going to solder the 2 wires exactly like that. Okay, we trim the excess. You don't want to short the entrance from the battery. That's it. Now our project looks okay. What's nice about the battery socket, it has a switch on off. Okay, so then we may even need to remove a little screw right here. So we have to find some screwdriver to do it. You have to give me a second. This was a bit unexpected to have the screw already put in place, so we have to remove it. Then we open the cover, and then we place the 2 batteries already checked right here inside. So we replace the cover, the switch being off, and now the moment of truth, we put them on. Take a look. The project is working. Let's press the button. Can you see it's going faster? Now it's going to go slower and slower. And then the medium one, it's exactly like the one we checked before. Okay? This is our project for today. Thank you very much, guys. See you for the next one. Bye-bye.